All right, let's see here. So if I've done this right, it's recording me, but I don't really know if it's done. So I'm going to assume that it's recording me. So for those of you who are watching this recording, you are just following along with us. But for those of you in class, here I want to think about this is a velocity time graph, right? So I want you to look at that velocity time graph. First of all, what does the slope of a velocity time graph tell me? Velocity is displacement over time, yes. But what does the slope of a velocity graph tell me? Acceleration, right? The slope of this graph should tell me acceleration. So I'm going to ask you a few things about it. First question, which way is it going? And again, you can click this if you want to see it again. But is it going forward, backward, or is it not moving? All right. You appear to have all fallen in my trap, except for Taylor. Everyone else fell into the trap, okay? This thing is actually going backward, right? So it has to be going backward, right? Because it has to be going backward because the velocity is negative, right?
Look at the zero.
Yep. So if this is 0, right, you see I'm at -7, then I'm at -5, and then I'm at -3, but my velocity is always negative. So if my velocity is always negative, it has to be moving backwards. All right, next question. Wait, it lets you change your answers? That's not fair. Okay. Is it speeding up, slowing down, or moving at a constant speed?
Yes.
Yes. All of them. It's doing all three at the same time.
Welcome back to my daily vlog.
All right. All right, let's see here. So we kind of are all over the place on this one. Let's think about this, right? So the way I like to think about it is, let me go back to, it's going to make you let you change it again, but that's okay. All right, so think about what's happening here, right? You see I'm starting at -7, then I'm going to -5, and then I'm going to -3, and then I'm going to -1. So my speed, right, which doesn't care about direction, what's happening to my speed? Well, the velocity might be going up, but the speed, right? Remember, speed doesn't care about direction. So -7 means I'm going 7 meters per second backwards. -5 means I'm going 5 meters per second backwards. So this thing is going backwards the whole time, but it's actually slowing down. So this thing is actually slowing down, okay? Now, just a reminder, looking back at your notes, right? What did we say? We said, how does a velocity graph tell me how fast? If it's far away from the t-axis, it's fast. If it's close to the t-axis, it's slow. So I'm going from far away to the t-axis to closer to the t-axis. So this thing's slowing down, okay? Let me ask a similar question. Well, actually, I'll have you, I think this is the next question. So the next question I want to ask you is, what is its acceleration? And again, you'll probably need to zoom into it in order to see, but can you calculate what number is its acceleration? You're not confident, Taylor? You're gonna put a question mark after your answer? You can, yes. Vincent, you're not confident in your answer? All right. Fair enough, Dayton. All right, so what I'm actually gonna say, so how do we tell the acceleration on this? Slope, right? So if I pick 2 points and I do a rise over run over the 2 points, right? So if I pick these 2 points and do a rise over run, I think it's 2 over 1. So 2 over 1, which is 2 meters per second squared. Now, a lot of you said it was -2. Why negative? Say again. Well, velocity is negative, that's true. Now, we said this thing was slowing down, right? Now, let's think about this. Do you remember if you are going backward, so you have a negative velocity, right? But you're slowing down, what kind of acceleration helps you slow down if you're going backwards? What, if you're going backwards, you have a negative velocity because you're going backwards. What kind of acceleration slows you down? A positive one or a negative one? A positive acceleration slows you down, right? Remember, because if you're going backwards, if you're going this way, you have to go against it to slow yourself down. So what actually is, this is actually positive 2 meters per second squared is the acceleration, okay? Because the slope is positive and also because positive slope would cause this thing to slow down. So I'm going to say that the slope or the acceleration in this case is positive 2 meters per second squared. Any questions about this? All right. I'm going to show you a different one. So here's a different one. So you see where 0 is and you see where the line is. So I'm going to ask similar questions. First question is, which way is it going? I appear to have tricked you again. All right. So let's talk about this, right? If you are, this would mean I'm not moving if it were what kind of graph? If it were a displacement graph, this would mean I'm not moving, right? But what I am moving, that is, the velocity is staying at 3 meters per second, right? So I'll let you, not that I can stop you anyway, but what is the answer then?
I got it right.
Yeah, you're going forward, right? So you should be going forward in this case because the velocity stays at positive 3 meters per second. All right, next question. Speeding up, slowing down, or moving at a constant speed? Everyone is right so far who's answered.
All right. That means it's slowing down. Is that still the case?
That's not the case anymore. All right. So if we look at this, right, we're staying at 3 meters per second the whole time, right? So we're going to say this is a constant speed. All right, 2 more questions that are asking for numbered answers. And when you give me a number, also give me its units, right? So what is the object's velocity? Oh, yeah. You can also, if you click this part on yours, you can see it too. All right, so. Just to be clear, I'm asking something different than I asked the last time. I'm asking velocity. The last time I asked for acceleration. The velocity, right, should be 3 meters per second, right? The velocity should be 3 meters per second because it's staying at that 3 meters per second if you look at that, right? Now, the next question is, how about acceleration? Yup. So I think we're pretty much in agreement, right? If you're going at a constant speed, right, that means your acceleration is 0. So if you're going at constant speed, you have no acceleration. All right, one more graph now. Here's one more graph, and then I'm going to have you draw some graphs. This question is asking, this is a displacement graph. So this follows different rules, right? So what does the slope of a displacement graph tell me? It doesn't tell me acceleration anymore. The slope tells me velocity, right? So this is the displacement graph. So looking at the displacement graph, which way is that on? Oh, I didn't put it in there. It's a velocity, or it's a I don't know. Does it let you go back?
No.
Okay. Here. I'll go back and I'll freeze it on the screen so you can see it. Try now. Good. So yeah, it's going forward, right? It's going forward because it's going up. Okay. All right, now speeding up, slowing down, or constant speed. Now you can look at it like that. All right, so again, remembering that this is a displacement graph, and therefore it follows displacement graph rules. Let's see here. I agree it's a constant speed, right? So the slope of displacement graph is velocity, right? So if I have a constant slope, so if I have a line, a velocity graph, that means constant speed. It doesn't mean that I have a velocity graph, but in a displacement graph, a line is going to mean constant speed. All right, tell me what the velocity is. this is looking pretty good. Just to be clear, so if you have, I'd like an answer that's kind of 3 meters per second. So if you give me an answer that's 3/1 or something, just calculate that out. 3 divided by 1 is 3, and then put a unit on it. So 3 meters per second would be the velocity. All right. Yeah, but actually that was Christian's answer. That's on the board. Sorry. Okay. Okay, what's this object's acceleration? You got to think about this a little bit. No. No.
That's what the question.
So it's actually, right, remember the slope of displacement gives me velocity, right? And we just said this is a constant velocity. If you got a constant velocity, what's your acceleration?
None.
0. So your acceleration for this graph is going to be 0. All right. Okay, let's do this the opposite way. I don't remember what my next question is. Oh, I got 2 graphs here. I'll put them up for you. So I want you to explain to me, so they look the same, except the first one is displacement and the second one is velocity. So the question I'd like to ask now is, what are they each doing? Right? What is the first one doing? What is the second one doing? They look the same, except they're different graphs. And when I say what's it doing, is it going forward, backward? And is it speeding up, slowing down, or going at constant speed? I don't think they're both going forward. First graph. So let me see here. I think this one's right. Let me read it more closely. The first graph, okay, so the first graph was the displacement graph. So it's going backwards because it's going down, right? Constant speed because it's a straight line. The second graph is going forward. Why is the second graph going forward? Remember what it looked like? this. This is displacement. So I guess I should be doing this so that the recorded people can see it. So the displacement is getting smaller. So that's why I'm going backwards. I'm going backward at constant speed. But this one, the velocity stays positive. So I'm going forward the whole time, but I'm slowing down. Okay? This one's backward at a constant speed. This one is forward, but slowing down. All right. Now we're going to do some drawing. Oop, I skipped it on. All right. If I'm going backward at a constant speed, what would that look like? See if you can draw both graphs for something that's going backward at a constant speed. I think there's a way to erase it.
Yeah.
I think.
Or convince if I click the eraser, just erase it.
We all seem to be right about the displacement graph at least.
He's right about
All right. Taylor, you want to explain for us? Wait, give me 1 second. I want to share it. There we go.
Oh, is, velocity is not accelerating or anything, so it's just staying at, whatever, -2.
Yeah. It's got to stay a negative velocity and not change, right? So it's got to be negative, so it's going backwards. It's got to be below the axis, right? But it's got to be going at a constant speed, so it's got to be flat. That's the velocity graph. We all got that backwards at a constant speed is just a diagonal for the displacement graph. All right, let's try. We got 2 more and then we're done. What about going forward and speeding up? Displacement left graphs are looking good. We are almost in agreement on these. All right, let's look at, Samantha, could I ask you to explain yours? Okay, it's right.
Is it really?
It is.
Oh, okay.
Yeah.
Well, because there's 1 4 and I don't know. I just
So we're forward because I'm going up in that first graph, right? Why am I speeding up?
mean why?
Look, how does it show me that I'm speeding up?
It's going up.
It's going up and it's getting steeper and steeper, right? Yep, so that's right. So that's the displacement. Someone want to explain velocity? Go ahead, Christian.
Velocity going up.
Yeah, and specifically, just to be a little bit more clear, it's not necessarily the fact that it's going up, it's the fact that it's getting further away from zero. Right? The fact that it's getting further away from zero means that it's speeding up, and then it's positive because it's going forward. You all right with this? It's supposed to be straight, I think.
Yeah, it's supposed to be
The
straight.
second one, oh, why isn't it? Why is it not curved? So it could be curved. I usually draw, so without more information, we don't know the actual shape of things. But we are gonna, in this class, mostly talk about things that have a constant acceleration, which will mean that the velocity graph is always some form of straight line. Technically speaking, if you had, I think I saw yours on here. Technically speaking, I can't say that that's what, well, maybe the first one needs to be curved a little bit more on the displacement graph. What are you laughing at? Actually, so let me go back. So this is Wes's, not that one. So this is Wes's, right? This is technically not wrong, but I usually just consider the velocity as a straight line because I'm assuming the acceleration is constant. Yeah. All right. I think I have one more. Backward and speeding up. When the bell rings.
This class is like twice as fun.
It's actually 119. We're actually doing all right.
Class is twice as fun all the time. It is
But I think who's your favorite teacher?
him or Mr. Kinney. Math. His name.
All right.
There's another Sam.
So again, I think most of us have something similar for displacement. There's a few people waiting to submit, so I'll give you a second here. This is it. Dayton, could I ask you to explain yours? Well, yeah, we'll start with the displacement one.
Is that correct?
This is correct, yes. Yeah.
I did the downward slope because it's going backwards.
Downward slope, good.
And then I did it steep because it's steep.
Yeah, so it has to go flat to steep because it's speeding up. So that explains the displacement. And then velocity. So let me ask you this. The velocity looks like it's going down. How can that be speeding up? It's going backwards. It is speeding up. Why is it speeding up? You know why the second graph is speeding up even though it's going down? How do we indicate speed, right? Remember, look at your notes. The thing that indicates speed is how close we are to the zero, right? So what I've got is I'm very slow here, and it's a negative velocity, and then I'm getting less and less, or farther and farther away from zero, so I'm getting faster and faster. Again, like I said, if I were drawing this, so this is correct. If I were drawing this, probably the way that I would do it is I would say, okay, for the displacement, I would do the same way. But I would probably draw it as a straight line, but that's basically the idea. Okay, any questions?
No.
All right, let me stop my recording real quick.
That was their recommendation?
This is not,